Namaste. Welcome to Pabson Distant Learning Education Program live in JanataTelevision. And so today, Grade 10 Science course we are continuing. Last time we have discussed about acceleration due to gravity. And today we will continue that acceleration due to gravity with some numerical problem. So let's quickly revise the previously what we have discussed. So some formula we have derived in last class, that is g equals to z m by r square. This is acceleration due to gravity at the surface of Earth. Similarly, g dash equals to z m by r plus s to the whole square. This is acceleration due to gravity at the certain height. And we have also derived the relation between this g and g dash. That is, g dash equals to r by r plus h to the whole square into z. And one more relations we have learned previously is g dash equals to 1 minus d by r into g. So these relations we have derived in the previous class. So today we will solve some numerical problem related to this formula. So let's see some numerical problem. You can see in the screen also. So first one, there is find the acceleration due to gravity on the surface of Earth if the mass of the Earth is 6 into 10 to the power 24 kg and radius of Earth is 6400 kilometer. So this numerical problem we are going to solve. So what is given over there? Let's list out. So solution here. There is given the mass of the Earth is given there. So mass of Earth. So I will represent this by capital M. There is given this 6 into 10 to the power 24 kg. This is the mass of Earth. Similarly, there is given the radius of Earth also. So radius of Earth. So I'll represent this by R. Radius of Earth is 6400 kilometer. And one more information is given over there, capital G. So capital G equals to 6.67 into 10 to the power minus 11 Newton meters square per kg square. So these things is given over there. And we need to find the acceleration due to gravity. So acceleration due to gravity. So symbol I will write down this z because it is at the surface of Earth. So we need to find this one, small g, we need to calculate. Now let's check the formula over there. So this formula is suitable for this. So we are using that formula. So we have z equals to z m by r square. So before solving this, so let's check the unit of the given over there. Either they all are in the SI system of unit or not. So this mass is given there kg. It is SI system of unit. Similarly, this radius is given in the kilometer. That should be in the meter. So let's convert this kilometer into meter. That is. So this one is 6400. This kilometer is there. To convert that kilometer into meter, multiply by 1000. Now this is meter. So we can write down this 6.4 into 10 to the power 5 meter. So let's put the value of this in formula. Equals to z is 6.67 into 10 to the power minus 11. So let's not write the unit. Later on we will write. This mass is given there 6 into 10 to the power 24 kg. And this radius is there. That is 6.4 into 10 to the power 5 to the square. So let's solve this one. So above one is 6.67 10 to the power minus 11 into 6 into 10 to the power 24. It gives 4.002. So this gives 4.002 into 10 to the power 14 into 10 to the power 14. And this one, next one, 6.4 into 10 to the power 5 to the square. That gives 4.096 into 10 to the power 11. So let's divide this 2. Then what will be the answer? Let's check. 4.002 10 to the power 14 divided by 4.09. It gives the answer of. So this one is G. And let me check this again. 6.67 10 to the power minus 11 into 6 into 10 to the power 24 kg. It gives the 4.002 into 10 to the power 14. And similarly 6.4 into 10 to the power, sorry, this should be 6. Okay, so this should be 6. So this one is 6 to the square. Now let me correct this. To the power 6, 6.4 into 10 to the power 6 to the square. It gives the 4.096 into 10 to the power. This is 13. Okay, so let's divide this 2. This is 4.002. 4.002 into 10 to the power 14 divided by 4.096 into 10 to the power 13. It gives the answer 9.7705. So this is acceleration due to gravity. So the unit must be the meter per second square. So lastly, you can write down the conclusion for this one. Therefore, the acceleration due to gravity of the Earth is 9.7705 in meter per second square. So lastly, you can write down this one. Okay, so similarly, next one numerical problem is there. So this kind of questions you can find in another question also, and you can try also for solving this one. So next numerical problem also there. So you can see on the screen the question. Second question is there. So this question is related to finding the acceleration due to gravity at the height, certain height. Okay, so let me read the question. Calculate the acceleration due to gravity at the top of Mount Everest of height 8848 meter above the sea level. The mass of Earth is mentioned over there, and the radius of Earth also mentioned over there. So this one is finding the acceleration due to gravity at the certain height. So let's see how to calculate this one. So let's write down firstly the given. So here, so firstly mass of Earth is given, mass of Earth. So this I will write down capital M. The mass of Earth is given over there 6 into 10 to the power 24 kg, right? Similarly, the radius of Earth also given over there, radius of Earth. So I will represent this by capital R. The value is given 6400 kilometer. So let's change this into meter. That is 6400. 1 kilometer equals to 1000 meters. So multiply by 1000. It gives the meter. So this one is again 6.4 into 10 to the power 6 meter. So how to count this? 1, 2, 3, 4, 5, and 6. That's why it's a 10 to the power 6, right? Similarly, the height of Mount Everest also given over there. Height of Mount Everest. It is also given. So this I will write down by small h, is given 8848 meter. This is height of Mount Everest. And one more thing we should write down here, capital G. Value is 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? And we need to find here the acceleration due to gravity, acceleration due to gravity at top of Mount Everest. So this I will represent by Z dash equals to what? So we have the formula for this. So we have the formula for this of G dash is Z dash equals to Z M by R plus S to the whole square. So this is at the certain height. That's why the distance will be R plus H. So this one is the distance from the center of Earth to the object, right? So let's put the value of this. G, it is 6.67 into 10 to the power minus 11, right? And mass of earth is there. Mass of earth, this one. This is 6 into 10 to the power 24 kg divided by R is there. This is 6.4 into 10 to the power 6 plus 8848 meter to the square, right? So we have, let's calculate this one. So multiplication of this 6.67, 10 to the power minus 11 into 6 into 10 to the power 24. It gives 4.002 into 10 to the power 14 divided by, so let's simplify this denominator also, 6.4 into 10 to the power 6 plus 8848, this one, and to the square. So let's square this. It gives 4.107 into 10 to the power 13. So let's divide this 2. That is 4.002 into 10 to the power 14 divided by 4.107 into 10 to the power 13. It gives the answer 4.002 10 to the power 14 divided by 4.107 into 10 to the power 13. So it gives 9.74 meter per second square. That's why the acceleration due to gravity at the top of Mount Everest is about 9.74 meter per second square. So we can calculate the acceleration due to gravity at the surface of Earth also by using the previous formula, and we can also calculate the acceleration due to gravity at the certain height. Like here we have taken the height of the Mount Everest. So by this method we can solve the numerical problem related to acceleration due to gravity. Okay, so same kind of questions you can find, and you can solve the few more questions so that you will be confident about this numerical problem. Okay, so lastly you can write down the conclusion also. That makes the numerical better. Okay, so one more numerical problem is there. So let's see. Let me read the questions. The radius of Earth is 6.37 into 10 to the power 3 kilometer, and the height of the Mount Everest is 8848 meter. If the value of small g on the surface of Earth is 9.8 meter per second square, then calculate the value of g at the top of the Mount Everest. It is a similar one, but we use the different formula for this one. So let's see what is given over there. So the given over there is radius of Earth is given. Radius of Earth. So let me write down this capital R. That is 6 point, there is given 37 into 10 to the power 3 kilometer. So it is not in SI system of unit. Let's change this into the SI system of unit. Kilometer is there. To change that into meter, multiply by 1000. That is 6.37 into 10 to the power 3 into 1000. Okay, so it gives, now this is meter, right? So it gives 6.37 into 10 to the power 6. This is point there. This is meter. Okay, so this is conversion one. And next given over there is height of Mount Everest. Height of Mount Everest, right? So symbol is small h. There is given 8848 meter. Height of the Mount Everest, right? Similarly, one more component is given over there. Acceleration due to gravity. Acceleration due to gravity at surface of Earth. Surface of Earth. It is also given over there. So surface of Earth, let me write down this g equals to 9.8 meter per second square, right? And we need to find the acceleration due to gravity. Acceleration due to gravity at top of Mount Everest. Okay, so symbol I will write down here, z dash equals to what? So here is not mentioned the mass of the earth. Mass of earth is not given over there. Radius is given and height is given, and one more thing, this acceleration due to gravity at the surface is given. That's why whatever formula we have used previously, that may not be suitable over here because mass of earth is not given. That's why we have derived this formula also. This g dash equals to r by r plus s to the whole square into z. So this formula is suitable because radius is given over there, height also mentioned over there, and g also given over there. So we use that formula. So we have g dash equals to r by r plus s to the whole square into z. So let's put the value of this here, equals to this r radius is given there, 6.37 into 10 to the power 6 divided by r is given over there again, 6.37 into 10 to the power 6 plus height is given over there, 8848 meter. So this to the whole square into 9.8. This is the value for z dash. So let's simplify this. So you also can solve with the help of calculator. So let me add this denominator first, 6.37 10 to the power 6 plus 8848 meter. That is, so let me write down this, 6.37 into 10 to the power 6 divided by 6378848 to the square into 9.8. So let me solve this. So directly I will solve 6.37 10 to the power 6 divided by 6378848. That gives, and let's square this and multiply by 9.8. It gives the value of, this is 9.772 meter per second square. So if there is given the acceleration due to gravity at the surface of earth, then with the help of that also we can calculate the acceleration due to gravity at the certain height. So by using this formula. Okay, so this formula we have used here. So let's remember this formula also. Okay, so this kind of numerical problem can be solved by this method. Okay, so next one, let's see. We have discussed previously some give reason also. So let's revise some give reason here. You can collect number of questions yourself and you can solve to make the confidence about the numerical problem. Okay, so let's discuss some give reason related to this acceleration due to gravity. Okay, we have derived previously the acceleration due to gravity is inversely proportional to the square of radius that we have derived. Especially for the give reason, this relation is important one for answering the give reason. Okay, so some of the questions I have brought. Okay, you can check on the screen also. There is mentioned some questions over there, like at which place of the earth the acceleration due to gravity is more and why. These questions we have discussed previously also. Let me revise this once again. Similarly, why the acceleration due to gravity is more in the Terai region than in the mountainous region. These two give reason we will discuss right now. Okay, so first one, why the at which place of the earth the acceleration due to gravity is more and why. So let's see. So earth, it is not completely round, right? It is oval in the structure. If we check the radius of this earth in this 2 point, let's say A and B, let's say center is O, then whenever we check the radius, then this radius, it is called the equatorial radius also. The equatorial radius is more than this polar radius. The polar radius is less and this equatorial radius is more, right? Now, if the radius is less or more, definitely the value also gets changed, because this acceleration due to gravity is inversely proportional with the square of radius. Inversely proportional means if the radius is more, the value of g is less, and if the value of radius is less, then the value of g is more. That is the inversely proportional mean, right? So let me write down this. This value of radius, this is of equatorial radius, right? It is more, right? If the radius is more, then definitely the value of g is less. That's why the value of g on this equator is less, right? Similarly, the radius of this polar region, it is less, right? It is less than this radius of equatorial region. If the radius is less, then it is inversely proportional, mean the value of g will be more. So here the value of g is in the polar region is more. That's why the value of acceleration due to gravity at the polar region is more than the equatorial region. Why? Because the radius of polar region is less, so the value of g is more, and similarly the radius of equatorial region is less, that's why more, that's why the value of g is less. So with the help of this relation, we can explain this kind of give region. Okay. Similarly, in the case of Terai region and the mountainous region, the value of acceleration due to gravity is more in the Terai region than in the mountainous region. That also can be explained with the help of this relation. Okay. So let's see how to explain. Okay. We know that the height of the Terai region is less than the mountainous region from the sea level, right? And if the height is less, we can also consider the radius also, no problem, right? So if the height of the Terai region is less, then in the same this relation also we have g dash is inversely proportional to the r plus s to the whole square, mean this acceleration due to gravity also inversely proportional with the height. So if the height is less in the Terai region, then the value of g is more, as the height is inversely proportional with the acceleration due to gravity. And if we check the mountainous region, then definitely the height is more. Height of mountainous region is more, that's why the acceleration due to gravity value is less on the mountainous region. So with the help of this relation, we can answer the give regions also. Okay. So okay, this is a revision that we have read previously also. Now let's discuss about the mass and the weight. So next topic for discussion is mass and weight, that we have discussed previously in grade 9 also. So let's revise this mass and weight. Okay. So we have defined the mass previously in grade 9 also, as a mass is the amount of matter contained on any object, right? Amount of matter contained in any object is defined as the mass, whereas the weight, it is the force of attractions of heavenly body towards its center. For example, the number of molecules are present on this duster, right? And the total number of molecule present on this duster represent the mass. That's why this mass is constant everywhere, that we have learned in lower class also, because it is depend upon the number of molecule present on the object. That's why mass is constant everywhere, right? Similarly, the weight is the force of attraction. For example, if I put this object here, then some certain force is there that is attracting this duster towards the center of the earth, right? And that force, it is simply known as the weight. So weight is the force of attractions of the heavenly body to the surrounding object. Okay. So this weight, it is measured in Newton, right? And this mass, it is measured in the kg. The SI unit of mass is kg, and other unit also there like gram we can use for measuring the mass, and the weight, it is measured in the Newton. Newton is the SI unit for the weight. Okay. Okay, and similarly this mass, we can measure this mass with the help of bin balance, right? And the weight can be measured by using the spring balance. So spring balance, we can use the weight, and the mass we can measure with the help of the bin balance. Okay. Okay, the differences between this mass and the weight is the amount of matter contained in the body, it is called the mass, and the force of attractions of heavenly body towards its center is called the weight. And similarly, mass, it can be measured on the kg in the SI system of unit, whereas the weight, Newton is the SI system of a unit for the measurement of a weight. And similarly, the mass, it depends upon the number of molecule present on the object. That's why it is constant everywhere. Whereas the weight, it varies from place to place. And why it varies? Because weight is calculated by the product of mass and acceleration due to gravity. And just previously we have discussed the acceleration due to gravity is variable one. It depends upon the radius one. That's why the small g value is variable. That's why the weight also vary from place to place. For example, if you take the weight of object on the mountainous region and in the Terai region, then definitely the weight will be more on the Terai region. That is due to the acceleration due to gravity. So it is differ from place to place, right? And I've already said this mass we can use for measurement of the mass, the bin balance, whereas the weight can be measured by using the spring balance. Okay, some numerical problem is there related to this mass and the weight. So let's see. Okay, one question is there, you can see in the screen also. How much mass can a man lift in the moon if he can lift 50 kg on the earth? So let's solve this numerical problem. The question is, solution here, mass of object that can lift, right? Mass of object that can lift is, so let's say this is mass on the earth equals to, let's write down this m1, okay? So it is given about 50 kg, okay? And acceleration due to gravity, let me explain these questions again. What the question says is, okay, I'm a person is there that I can lift up the 50 kg mass on the earth. Okay, whenever I carry any object, the maximum mass that I can carry is 50 kg, let's say. Okay, if the same person, if I try to lift up any object on the moon, then what will be the mass that I can lift up on the moon that we are going to calculate? I think the question is clear one, right? The same person will carry the object in the earth, and the same person, the object will carry it on the moon. The object may be different one, but the same person will carry. In that condition, what is the amount of mass he can carry on the moon that we are going to calculate, okay? So for this, the mass is given over there, and acceleration due to gravity of earth as well as acceleration due to gravity on the moon, that both is required one, which we have discussed previously also, right? So acceleration due to gravity of earth, so this I will write down, this this is, let's say, g e, this is acceleration due to gravity of the earth is 9.8 meter per second square, okay? And similarly, the acceleration due to gravity of moon, so this is z of moon equals to 1.67 meter per second square, okay? So mass of object that can lift on moon, that is m2 equals to what? Okay, so here is whatever energy I have in the earth, the same amount of energy will be there in the moon also. That means the weight I can lift off on the earth, the same amount of weight I can lift off in the moon also. So in this case, the weight lifted on the moon is equals to the weight lifted on the earth, right? So now, so let's say this is weight lifted on the earth equals to weight lifted on the moon, right? So this one is m1 z of earth equals to m2 z of moon, or this is given here 50, this one is given 9.8, M2 we need to calculate, and this is 1.67 is there. So whenever you calculate this, then you will get the answer. So let's calculate this. This is 50 into 9.8 equals to divided by 1.67. It gives the answer about. Therefore, the M2 equals to 293.41. It's a kg. That's why if a person can lift up the 50 kg mass in the earth, then he can carry 293.41 kg in the case of a moon. Okay, so today we have discussed some numerical problem related to this acceleration due to gravity and the weight. So in next class we will continue some more related to this one. So till then, thank you very much everyone for joining this. Thank you very much.